students, welcome to mathematics class. And recently we discussed about the inequalities. Within that, especially modulus functions, modulus inequalities, logarithmic inequalities, and then finally exponential inequalities. So after that, today I am going to start a new chapter which is very important, that is coordinate geometry. Coordinate geometry is a very important chapter which is a combination of algebra and geometry. So this one can also be called as Cartesian system as well as analytical geometry. Okay, so before going to discuss about coordinate geometry, let me want to introduce the system which is called coordinate system. Okay, so which is the entirely different from the things what we learnt till now. So let us concentrate more so that you can easily understand the concepts as well as you can do your better, right? So coming to coordinate geometry, first we will be concentrating on what is the coordinate system. Are you ready, ma? So first of all, let us discuss about what is a line, what is the line segment, what is the ray, etc. Okay, so coming to first point, let A comma B, let capital A comma capital B be any 2 points in a plane. Let it be any 2 points in a plane. Then look at the point number 1, that is generally the distance between capital A and capital B is denoted by AB. So in this chapter, especially whenever we see the words, the terms like AB, BC, AP, PQ, etc., the meaning is nothing but distance between those 2 points. Here suppose A and B are the 2 points and the distance between them is denoted by capital AB. The meaning is nothing but distance between the 2 points capital A and capital B. And coming to the second point, the line segment joining capital A and capital B is denoted by AB bar. So look at this. The meaning of AB bar is nothing but line segment joining the 2 points which are capital A and capital B. So this is the meaning of AB bar, that is the line segment joining the 2 points capital A and capital B. And coming to the point number 3, the ray from capital A and passing through capital B is denoted by AB in this manner. This direction, only one direction we are mentioning, that indicates it is a ray. AB ray we can denote in this manner. The meaning is, this is the thing, a ray which is passing through the 2 points capital A and capital B. Still it is extended, it is a ray, no, is passing through the 2 points. Now the point number 4, the line passing through capital A and capital B. So please do not confuse, the second point is nothing but line segment. Line segment is a part of line, whereas now I am talking about line. So the line which is passing through capital A and capital B is denoted by AB to the both directions. The meaning is, this is the meaning. So a line which is passing through 2 points capital A and capital B. So please do not confuse about these basic notations, right? So let me want to revise once again. The meaning of AB, if you write AB, the meaning is nothing but distance between 2 points, that is A and B. If I mention in this manner, AB bar, this is the notation of the line segment of joining 2 points A and B, capital A and capital B. And suppose if we mention in this manner, now this one direction which is clearly gives us that it is a ray, the ray which is passing through A and B. Okay, and finally the fourth notation is AB with both the direction, and this means a line which is passing through the 2 points capital A and capital B. Okay, so these are the basic notations. AB denotes the distance between 2 points. AB bar denotes the line segment joining 2 points A and B. And AB ray, this is so clearly a ray which is passing through both A comma B. And this indicates the line passing through the 2 points capital A and capital B. Okay. So now let me want to explain about coordinate plane. So to explain this concept, let me want to consider two mutually perpendicular lines. Let me want to consider two mutually perpendicular lines. Okay, so let us assume x dash x and y dash be two mutually perpendicular lines, and these two are intersecting at a point, say some O. Okay, so to explain this concept, let me want to consider two mutually perpendicular lines. So one of the line is x dash x, and let it be a horizontal line, and y dash be a vertical line. So since one is horizontal and one is vertical, definitely they both are intersecting at a point. Hence assume the point as O. Now this O is nothing but origin. The point O is called origin, and the line, the horizontal line, especially horizontal line. What is the horizontal line here? Horizontal line x dash OX. Isn't it? Line no? Can be extended furtherly both directions. The horizontal line x dash OX is called x axis. And similarly the vertical line. Can you say what is the vertical line here? Line y dash is called y axis, and the point of intersection of x axis comma y axis is called origin. And denoted by starting letter of origin O, and the coordinates of origin O are nothing but 0, 0. Okay, and this x axis and y axis together we call it as coordinate axis. Together we call them as coordinate axis. So let us assume capital P be any point in the plane. P be any point in the plane. Now draw the perpendicular from P to the x axis which meets the x-axis at capital L. Also draw the perpendicular from P to y-axis which meets the y-axis at a point, say some capital M. If not, we can also call them as L comma M, capital letters, capital L comma M be the projections of P to the x-axis and y-axis. So projections are nothing but feet of the perpendicular. See, nothing but this is the feet of the perpendicular. This is the line which is a perpendicular line. For this, L is a point which is a feet. Similarly, M is also feet of the perpendicular. So one way we can call them as projections also. So finally what I want to say, let capital P be any point in the plane. Now draw the projections from P to the x-axis and y-axis. Hence they meet x-axis at the point capital L and y-axis at the point capital M respectively. Right? Now look at me here. O is the origin and L is a point on x-axis. So I think L has some value, no? Since it is a point on x-axis. Earlier we discussed especially in terms of intervals, plotting the graphs, nothing but some values. L has some real value. So let it be say some the real value, say some x, and similarly the real value of M you can say some y. I mean, you know, the directional distance from O to L, this entire distance is equals to some x units. Similarly, this distance from O to M, which is equals to y units. Okay, let x comma y be the real numbers which are assigned to capital L comma capital M respectively. Hence the point P is denoted by, isn't it? The point P is denoted as small x comma y. Here x denotes x coordinate and y denotes y coordinate. So therefore together x comma y are the coordinates of a point capital P. Right? So what is x is called here? X coordinate, and small y is called as y coordinate, and finally the point P is denoted as Px comma y. I mean x comma y are the coordinates of a point P. Generally there may be a point, suppose 1 comma 2, say some Q. So 1 comma 2 are nothing but the coordinates of a point Q, where 1 is the x coordinate and 2 is the y coordinate. So my dear students, from this we can understand that every point in the plane can be represented by two real numbers. So let me repeat once again. Every point in the plane can be represented by two real numbers, small x comma small y, and every pair of real numbers determine a point in the plane. Do you understand here? So every point, not only here the point is P, no, there may be somewhere here one more point, somewhere here one more point. So say suppose Q, say suppose this is Z, or say K. So every point can be expressed as a pair of real numbers. Similarly vice versa, every pair of real numbers are nothing but denotes a point in the plane. For example, if you take minus 1 comma 2, nothing but it is a particular point. So if you take 5 comma minus 3, it is also a point. So every pair of real numbers denote a point in the coordinate plane. Okay. So x-axis and y-axis are together, we call as coordinate axis, and this entire plane is called coordinate plane. So this entire plane is known as coordinate plane. Right? Now these two coordinate axes are dividing the plane into 4 equal parts. So both the x-axis and y-axis together, they are dividing this entire plane into 4 equal parts. Part 1, part 2, part 3, part 4. So nothing but 4 parts, no? That's why we call it as a 1/4 part. What is the generally we use for 1/4 part? Is nothing but quarter. So hence these 4 parts are individually called them as first quadrant, second quadrant, third quadrant and fourth quadrant. So finally, both x-axis and y-axis are dividing this entire coordinate plane into 4 equal parts, and each part is known as a quadrant. Okay, known as a quadrant. So first quadrant, second quadrant, third quadrant and fourth quadrant. First quadrant usually we denote with Q1, followed by Q2 for second quadrant. Third quadrant is denoted by Q3 and fourth quadrant is by Q4. I mean quadrant 1, nothing but the region capital X, O, capital Y. And quadrant 2 region is nothing but capital X dash, O and capital Y. Okay, so look at me. First one is nothing but capital X, O, Y. This region is nothing but quadrant 1. And second quadrant is X dash, O, Y. Second quadrant. And third one is X dash, O, Y dash. This region is nothing but quadrant 3. And finally X, O, Y dash, the region is denoted for quadrant 4. Now let us see some interesting facts about these quadrants now. If suppose in the first quadrant, now look at me, this is OX is considered as a positive x-axis and OX dash is considered as negative x-axis. Similarly, OY ray is nothing but, this is nothing but, the part is the OY part is considered as a positive y-axis and OY dash is called negative y-axis. Suppose in this region, since OX is the positive and OY is also positive, both are positive coordinate axis, hence x coordinate is always positive and y also positive. So if a point P lies in the first quadrant, hence its x coordinate and y coordinate both must be positive. And similarly, if you come into the second quadrant, here x-axis is a negative x-axis, whereas y-axis is positive. Here x must be less than 0 and y must be greater than 0. X is a negative x-axis, that's why x should be less than 0. And y coordinate should be positive because of it is a positive y-axis. And coming to third quadrant, see OX dash and OY dash. Both axes are negative axis. Hence x coordinate is less than 0 and y coordinate is also less than 0. Both coordinates are negative. And in the same manner coming to here, because of OX, x coordinate should be positive and because of OY dash, y coordinate should be negative. Do you understand now? So now suppose P is a point which is 1, 2. Let us see location of this point now. So when you look at about this point, first confirm with the coordinates. So x coordinate is nothing but 1 and y coordinate is nothing but 2. And both are positive. X is positive and y is positive. And this is the case. It is quadrant 1. Hence P 1, 2 belongs to quadrant 1. First quadrant. Okay. Not only 1, 2 my dear. 3, 4, 5, 6. 8, 10, etc., etc. So all these points, if you observe that both x and y coordinates are positive, hence they belongs to quadrant 1. Now suppose Q is a point which is minus 1, 2. Look at me now. So x coordinate is negative and y coordinate is positive. So where it is possible? I think this is the case. X is negative and y is positive. Hence Q belongs to quadrant 2. So this is the point, somewhere lies here in this quadrant somewhere. Okay, right. Now suppose R is the point which is minus 1, minus 2. So both are negative. X coordinate is negative, y coordinate is negative. So which is the criteria for the point to be lies in the third quadrant. Hence R belongs to quadrant 3. Fine. And finally, S is the one more point that suppose if it is 1 comma minus 2, I mean x coordinate is positive and y coordinate is negative. So where it is possible? In fourth quadrant. So which is belongs to Q4. So my dear students, so with the help of sign of the x coordinate and y coordinate, we can decide the location of the point. Okay. So from this concept, what we learned is nothing but how to locate the point and how to identify the location of the point. So this is what, depending on the x coordinate and y coordinate. If both are positive, then the point lies in first quadrant. If both are negative, then the point lies in the third quadrant. If x is positive and y is negative, then which lies in the fourth quadrant. And if x is negative and y is positive, hence the particular point lies in the second quadrant. Okay, now let us see what happens if x is equals to 0. If x is equal to 0, I mean suppose this is the point 0 comma 4. Let it be say some capital A is a one of the point 0 comma 4. Now look at me here, x is 0. So 0 cannot be treated, I mean as a positive or as a negative. It is neither positive nor negative. Now x coordinate is 0 whereas y coordinate is positive. So when x coordinate is 0, hence that point will be lies on y axis. Lies on y axis. So and similarly B is the one more point that suppose 4 comma 0. Now look at me, okay, x coordinate is positive but y coordinate is neither positive nor negative. So y coordinate is clearly 0. So that implies, so if a point where the y coordinate is 0, hence that point is lies on x axis. So if the point P lies on the x axis if and only if y coordinate is 0. Similarly, the point is lies on the y-axis if and only if x coordinate is 0. So look at me here. For example, in the case 1, here capital A, x coordinate is 0. Hence x coordinate is 0. If you look at 0 comma 4, x is 0 and y is somewhere here 4. Hence this may be the point of some 0 comma 4. Hence 0 comma 4 is a point on y-axis. So if it is on y-axis, if x coordinate is 0. And similarly, it is a point on x-axis if y coordinate is equals to 0. Hence, my dear, equation of x-axis is nothing but y is equals to 0. And similarly, equation of y-axis is nothing but x is equals to 0. Okay. If suppose both coordinates are 0 and 0, I mean x coordinate is 0 and y coordinate is 0, hence the point is on origin. It lies as origin. Okay. So now equation of x-axis is nothing but y is equals to 0. And equation of y-axis is nothing but x is equals to 0. So please remember that any point, if it is lies on x-axis, if must lies on x-axis, that indicates its y coordinate must be 0. Similarly, if any point should lie on y-axis means its x coordinate must be 0. If both the x coordinates and y coordinates are both are zeros, then nothing but which is denotes origin. The point lies on the origin. So coming to note, let capital A x1 comma y1 and capital B x2 comma y2 be any 2 points in a plane, then AB is a horizontal line if and only if y1 is equals to y2. So these 2 points, the line joining, the line whatever it may be, represents a horizontal line if and only if their y coordinates are equal. y1 is equals to y2. And AB is a vertical line if and only if their x coordinates are equal. That is x1 is equals to x2. So this we can explain with a example ma, let it be x-axis and y-axis. Now look at me clearly, this is the point which is some 1, 1 and this is the point some 2, 2. If you join AB, so we got AB is a horizontal line. Then in this horizontal line, if you observe the y coordinates, so both the points y coordinates are same. So that is what I am telling you here. If AB represents a horizontal line, then their y coordinates are equal. That is what you can observe here. Similarly, you know, this is the point which is 3, 1 and this is the point say some 3, 3. Say suppose this is P and this is the point Q. Now if you join PQ, so what we are getting? A vertical line. PQ is a vertical line. See, now if it is a vertical line, look at their x coordinates. So if it is a vertical line, then x1 is equals to x2. That is what x1 and x2 both are equals to 3. So from this, my dear, please remember that AB is a horizontal line if and only if their y coordinates are equal, and AB represents a vertical line if and only if their x coordinates are equal. So coming to the first concept, very important one. When 2 points are given to us, capital A x1 y1 and capital B x2 y2, then here we will discuss how to find the distance between any 2 points. How to find the distance between the given 2 points capital A and capital B. So let us coming to proof. So please consider the coordinate axis, that is both x-axis and y-axis. Say some capital A x1 y1 and capital B x2 y2 be any 2 points. So not necessary to be in the first quadrant itself, can be anywhere. One can be in first quadrant and one can be even in second quadrant. Okay, anyhow, let me want to consider A and B are any 2 points. Now draw the perpendicular from A to the coordinate axis, I mean x-axis, and similarly from B also to the x-axis. Say these 2 points as P, Q. Also draw the perpendicular from A to BQ, which meets at point say some C. Right? Now clearly you know, if A is x1, then OP is also x1, and this is nothing but OQ is equals to x2. So clearly this is the x1 and this is the x2. Now this distance, this distance is equals to x2 minus x1. Okay. Similarly, this difference between the y coordinates, this is equals to difference between the y coordinates, which is y2 minus y1. If PQ is x2 minus x1, then no doubt that which is also equals to AC, which is also x2 minus x1. Now you clearly see AC is nothing but x2 minus x1 and BC is nothing but y2 minus y1, and moreover in this right triangle ABC, angle C is 90 degrees, a right angle triangle. So we can apply Pythagoras theorem. Okay, so since ACB is a right angled triangle, then using the Pythagoras theorem, square of the hypotenuse is equals to, AB is the hypotenuse, no? Square of the hypotenuse is equals to sum of the squares of the remaining 2 sides, that is AC square plus BC square. This is because of Pythagoras theorem. So what is AC? AC is nothing but x2 minus x1 whole square plus BC is nothing but y2 minus y1 whole square. And from this I just want to know what is AB. Therefore AB is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square, which is known as formula to find distance between the 2 points when A is x1 y1 and B is x2 y2. So now let us find distance between some points using this formula. So please remember the formula, everybody. That is AB is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square, which is nothing but difference of square of the x coordinates and difference of plus difference of square of the y coordinates. So some of the teachers, they may write even the same formula as, instead of x2 minus x1 whole square, we can also write it as x1 minus x2 whole square. I mean, we can also write the same formula finally in this manner also. So x1 minus x2 whole square plus y1 minus y2 whole square within the root. So both are nothing but same. So let us this a basic fundamental problem, an example. How to find distance between a pair of points. So first pair is 7, 8 and minus 2, 3. So you can assume first point as capital A and second point as capital B. So denote the first point as capital A, second point as capital B. And always the pair is x comma y. No problem, anything you can consider as x1 y1 and anything you can consider as x2 y2. I mean, need not to be considered this as first point and this as second point, whatever it may be, but the order is important. Coordinates are always x comma y. So if it is first point, x1 y1. If it is second point, then x2 y2. So the formula to find distance between the 2 points, first of all notation AB, isn't it? The notation AB stands for distance between these 2 points, and using the formula under root of x2 minus x1 whole square plus y2 minus y1 whole square. So x2, which is minus 2, minus x1 is 7, minus 2 minus 7 whole square, which is minus 9 whole square, which is 81, plus y2 minus y1. y2 is 3 and y1 is 8. 3 minus 8 whole square, which is minus 5 whole square, which is 25. So 81 plus 25, which is 106. So AB is equals to square root of 106 units. I mean, there is no a finite value for this, isn't it? Exactly, we don't know. No? It maybe comes under 10 point something. So distance is some 10 point something units. No problem. And coming to the second problem also in the same manner, this time let me want to consider the both points as one is P and one is Q. And I want to find out the distance between them, hence the notation is PQ. Okay, so using the formula x2 minus x1, 2 minus of minus 8, which is plus 8. So 2 plus 8, 10 whole square, which is 100. And y2 minus y1, which is 0 minus 6 whole square, which is 36 actually. So 100 plus 36, finally 136. Hence the distance between P and Q, which is equals to under root of 136 units. I hope everybody enjoyed this class. Thank you for watching this video.